Hi everyone, welcome to InfluenceNow podcast. Today, our special guest is Manny Puentes, CEO and founder of Rebel AI, actually a Colorado-based company, hence his hat. And so we're practically neighbors, which is great. This is unusual for our blockchain guests. And he's going to talk to us a little bit today about what Rebel AI has going on and what it's doing to disrupt advertising and digital advertising. So Manny, if you want to go ahead and give us a little bit of background on you, and then we can dig into a little bit about what Rebel AI is just in general to start with, and then we'll go down into some of the problems it might be solving in the future.
Yeah, for sure. So Manny Puentes, CEO and founder of Rebel AI. I've been in Colorado for 20 plus years. Been working on advertising platforms since 1997. Building DMPs and SSPs and bidders and everything you think of in advertising. And then basically have watched the evolution of media trading and basically thought, wow, there's no better time than secure all the media trading than there is now, given all of the transparency and fraud issues.
Yeah, no, the fraud issues seem to be, especially with the stuff going on with Facebook right now, it's in the news, the trending stuff with privacy. I see a big need for this, and especially with regulations that might be happening. So can you explain to us maybe a little bit about what the advertising fraud problem is, and maybe anything you have around that to help our audience understand what that really is in the ecosystem?
Right. I would say there's a lot of different classifications when it comes to fraud, right? So there's human, non-human. What we're actually setting out to solve is what they call domain spoofing. So what that is basically when in the advertising ecosystem, those that are familiar with a DSP they're far away from the actual publisher, right? So the way that advertising works is when you load a web page. That web page calls an advertising platform. And as soon as it hits the advertising platform, there's a whole mess of transactions that happen. And they're basically not, they're all based on a protocol called HTTP. And so HTTP doesn't have a lot of the reporting and auditing that you need to start to understand how these transactions are taking place. And so essentially, in a nutshell, to make it simple, I actually have an example of everything that's going on within a browser. But in a nutshell, what's happening is the demand side platform or an SSP, depending on how far away they are from the publisher, they can't really tell if they're really buying, let's say, a New York Times, right? So, or they don't know if they're really buying CNN.com. And the reason for that is because those sites are just identified within the protocols as a string, right? And there's no security around that. So anybody can just change the string within these protocols and call it good, make money off of somebody else's brand, make money off of all the hard work that publishers have put into creating their content. And it's just something that needs to be solved in advertising, and that's the class of fraud that we're solving.
So to make it a little simpler for everyone to kind of consume, and myself, this is like, say we have a New York Times is selling advertising through various display advertising networks, and this advertising, how it's distributed, is exactly what you talked about, but then there's also the spoofing that occurs is these other websites basically make themselves look like New York Times, and then they run the ads even though the traffic isn't the same, so the user base you're actually reaching out to and paying for, it's not getting you what you want, especially when you're paying for impressions or click-throughs. It might not be the audience that you're looking for because these aren't real websites. Is that the correct way to understand this?
Yeah, I mean, that's one version of it. There are sites that make themselves look like New York Times, and they play a lot of games to make that happen. Another version would be someone sets up a data center and then creates these advertising bots and make fake requests to these advertising platforms, and the DSPs or other platforms don't really realize it's just a server farm inside of a data center. So there are a couple of ways to actually execute on domain spoofing, but with blockchain and identity and public and private keys, we have that solved now.
So leads me to the next question. Nice work, Manny. To how does Rebel AI solve the problem? So if you can explain a little bit about that, maybe, I don't know, you said you might have a visual for us too. I know we got an audience network that's audio, so I know you probably walk us through that. But how does Rebel AI solve this problem?
Well, first and foremost, before we go into exactly how we solve it, I'd absolutely love to show you the complexity of the advertising ecosystem. So what I've done here is I took the open source version of a browser because it's called Chromium. And I needed to be able to show exactly all the transactions that were happening. And it's really hard to do this. You plugins and other components that you can put into a browser don't allow you to show you or to access what I'm about to show you because of security models. And so I had to go deep down into the browser, into the memory model, and figure out how all of these IDs correlated. And these IDs that I'm referencing are called iframes. And so let me actually pull that up and then kind of show you what the advertising ecosystem looks like, what we're dealing with, and the complexities of what's happening. So let me screen share this. Okay, so essentially what you're seeing there is a pre-rendered graph of New York Times. Or actually, this is MSN.com. So this is already rendered, but I'm actually going to reload the page now. So what you're about to see is this graph dynamically create itself. And those orange dots that you see on the graph are basically iframes. And in the past, nested iframes, it's hard to actually traverse nested iframes because of the browser security model, but in this case, you're actually going to be able to see it. And so I'll walk you through some of the things that you're seeing here once I reload. So I'm about to reload MSN.com news.
And for the listening audience, but what we're looking at is a tree diagram that's dynamically changing to show the complexity and what's attached to the iframes and all the different calls that are happening. Is that correct, Manny?
That's correct. And I'm also scrolling down in the page because the JavaScript around the advertising, the 300 by 250s or the 728 by 90s or whatever sizes have what they call viewability wrapped around them, viewability tags. And so I have to. What you don't see is that I'm actually scrolling down in a browser to execute some of these tags, so that once they get in the viewport of the browser, they'll actually start to fire a lot of the advertising calls. So, and every page load is different. It's like depending on the platform that's actually trying to serve an ad will result in a different graph, because some platforms work with other platforms that work with other platforms, and then all of a sudden you've got this giant graph of advertising platforms that are trying to serve a creative inside that 728 by 90. So this is I'm going
to kind of cut you off there just to make it a little easy, Manny. I'm sorry to do that, but so what we're really looking at here is if somebody was on the front end looking at MSN.com and they were scrolling down the page, and as the advertising pops up down the page, these different calls are happening, just so everyone understands it.
Yeah, that's correct. So when you load up the page and you start to scroll down the page, it starts to, once the advertisement becomes in view within the viewport window, then the viewability scripts kick in, and then they make the call to the advertising platform. So what they're trying to do is only display the ad if it's in view of the browser to have a higher probability of the actual individual seeing it. Right? And so you have to write a browse, or you have to have a browser in order to execute these scripts so that you can actually graph the transactions.
Got it.
Right. So as you can see here, you've got AppNexus. You have. Let's see. There's this little here. You have Distillery. You have Magnetic, and a bunch of these DSPs that show up. DoubleClick, Trade Desk, all these little, what you see, these little cameras here are basically cookie syncing pixels, right? And that little blue, those little blue dots are JavaScript. And so when DSPs, what they call demand-side platforms, are setting cookie profiles or setting cookies so that they can actually identify profiles when they're purchasing inventory, they drop these little pixels here that you see. So usually when you see something like AppNexus and then all of those pixels that are being dropped are probably the demand-side platforms that are going to be buying through that SSP.
So the problem that exists again is that sometimes these sites will be spoofed, so the calls won't be secure. Is that correct?
That's right. So essentially, I'm loading this in a browser, but this could easily be a browser inside of a data center, right? And the people on the buyers on the end don't really know that it came from a data center, and they just assume that because the string inside of the HTTP protocol that delivers the OpenRTB request says MSN.com, they just assume that, okay, well, this is the best that I have to know directionally that it's MSN.com, and I'm going to go ahead and buy the audience that I'm looking for, right? And so that's where the problem comes in, is because these platforms aren't connected directly or have no mechanism to know or have the transparency to know that it is MSN, then it's just a guessing game. And so that's opened up the opportunity for fraudulent activity to happen and people to make a lot of money off of brands like CNN and Business Insider, so on and so forth.
Yeah.
So it's really complex, right? I put this graph together to show you that, in order to actually solve this problem, you have to integrate. You don't have to, but there's a lot of different approaches integrating with every single platform, which can take a really long time, or figure out innovative ways to capture and secure all of these transactions and start to deliver a quality for the advertiser and start to and really protect the publisher's identity, right? Because the economics around a publisher, essentially they have a VP of sales that goes out and says, hey, we work hard to curate an audience. We work hard to curate the content. Here's our demographic makeup. And they go out and sell their audiences to these DSPs or and create private marketplaces. And they'll say, hey, well, we'll sell you our inventory in a private marketplace for, I'm making this number up, $10 CPM, right? And the DSP will say, well, why would I pay $10 for it when I see it on the exchanges for $1.50? And they say, well, that's impossible. How is that possible, right? And what's really happening is it's these data centers or fake sites that are putting their inventory on the market at a cheaper price. And these machines are just basically running conversion metrics. And the spoofers and the bots out there have gotten really smart on how to set their own cookies, go and essentially build cookie profiles that are going to have a higher propensity to be bought, and it's just a mess, right? And blockchain and security and identity is really brought a game-changing technology to help with all of this.
So that does now we can talk about Rebel AI and how Rebel AI is solving this problem utilizing the blockchain. So if you can get a little bit into, just without getting too deep into it, just some generalizations on how Rebel AI is really solving this.
Yeah, for sure. So one of the things that's really important is that in a blockchain environment, you need a common transaction, right? You need something that identifies the transaction, that allows you to increment and decrement value, right? So it's just the whole common, that's just how a ledger works, right? And so you see all of those transactions that are happening within that graph. So imagine a world where a typical flow is I go to my browser, I type NewYorkTimes.com. That transaction is going to go to what they call a content delivery network. And that content delivery network is basically a bunch of servers that are spread across the world that serve the content for New York Times. When that content hits the browser, you saw all of those advertising transactions that were happening back and forth. Well, right now in advertising, the way that IDs are passed around from platform to platform are what they call macros, right? And so when I first started Rebel AI, I started to look at how all of these platforms are transacting. And I've been doing it for 20 years, so I kind of already knew, but I wanted to look at every aspect of how we would get blockchain inside of this type of environment. And what I found really quickly was there's not a common transaction ID. And because there's not a common transaction ID, it's when, advertisers, when they're looking at their reporting, they're going to want to know what ad ID, what creative ID, where it was actually served. And so you have all of this metadata that an advertiser is expecting in their reports, right? Okay, so now let's go back to the transaction ID component of it. Well, in order for this to work, the first thing you'd have to do is you'd have to have all of these platforms play in harmony, right? And they would have to start with a unique transaction ID at the top of the request, and then it would go to one platform. That platform would redirect to another platform, but before it redirected, it would have to actually resolve that transaction ID and put it on the next call. And so as these calls are going back and forth between the browser, those macros will have to continue to resolve. And that's where a big problem comes in when it comes to putting blockchain in advertising. And so that's whenever I started to go to the drawing board and figure out, how am I going to get blockchain in this environment with this transaction problem? And even if I solve the transaction problem, I still have a problem with operational errors, right? So if somebody gets the macro wrong, and let's just say you have 10, 15 platforms, all of a sudden I can't ever deliver a solid solution, because if they get the macro wrong, then my transaction ID is wrong, and now I can't, provide the reporting and the transparency that I need to give to advertisers and publishers alike. And so essentially, once we got to the drawing board, I said, okay, this is how we'll solve it. So we actually integrated within that content delivery network, and we established a wallet on that network. And that has the public and private keys. So now when you go to a browser, Rebel AI is installed, you go to NewYorkTimes.com, we'll digitally sign that page. So the request will go to CDN, we'll take the private key, we'll encrypt. We have a digital package that gets created. It's an unstable package, so you can't take it and put it on another page because it expires and none of the variables will match. And now imagine a world where you have a browser, it's an authenticated page, and if anybody wants to co-author within that page, they're going to have the corresponding keys and signatures. So that's the top where, that's basically where the transactions start at the publisher. Now, if you're an advertiser, essentially what you do is you take a traditional workflow would be that an advertiser would talk to an agency would create all the media assets, upload those into a third-party tracking server, let's just say DFA, and they take that tag and they put it into what they call demand-side platforms. And what they're doing in those demand-side platforms, they're just trying to find audiences, and they're trying to convert on those audiences, and they're trying to do it within the context of the page, right? So they're trying to find a reader, for example, trying to find a reader at Williams Sonoma and not at 7-Eleven, right? If they're an advertiser that's interested in recipes. So in that model, the additional workflow would be that instead of scheduling that DFA tag inside of the DSP, they would send it to our platform, and we would give them back digital signatures. And we would say, where do you want this ad to be delivered via its digital signature? And so you can choose the individual site, or you can choose the curated marketplace, or you can choose a deal ID, right? All of them are going to be digital signatures. So essentially, once you push, let's say, a marketplace to get a lot of scale, we would give them back a digital receipt with a different tag that represents the original tag they put in, right? So now they go schedule that in a DSP, and that tag can go anywhere it wants. It could be resold 1 billion times. It doesn't really matter, because unless it lands on the site that matches the digital signatures, it's not going to render the creative. And that completely eliminates domain spoofing, because unless you're the NSA and have a backdoor into cryptography, it's either right or it's wrong, right? There's no probabilistic approach. It's 100% deterministic, and it's real time, and it's a game changer. And now essentially what we've done is you've established a wallet on the CDN, and essentially once you have that wallet on the CDN, the second phase to that is to start batching those transactions and putting them on a distributed ledger. So now you know exactly what the page views are, and now you have a distributed ledger that's public knowledge that says here's everything. Here's all the page loads that happen with inventory availability, right? Now that's a contractual agreement, whether the publisher wants to do that or not. So they can still have the identity components and the security around media trading. And if they opt into a public ledger, they can do that as well. But this is really new, right? So we have to get comfortable with what we're sharing and what's in a distributed ledger and all the politics and social aspects of what that means. So what I'm really excited about is that we've solved the identity and domain spoofing problem, and now we're going and socially educating the market about what it means to be in a distributed ledger. And then we start to push this forward. So think about our technology. In everything you saw in the middle of that graph, we essentially just bookended the advertising ecosystem, and we apply security in that manner. And it becomes easier, and then you can roll it out into an advertising ecosystem and actually have a solution for a problem that's happening today.
So it's gated with encryption and verified through the hyperledger.
That's right.
And
that's right.
Is there a particular? I think it's revolutionary coming from a marketing space and doing digital advertising myself. That this is revolutionary in that I know that advertising is going to go where I want it to go. I know it's going to be secure. I know publisher identities are going to be secure. So this, to me, is revolutionary, and so glad to talk to you about this. So there is as far as the hyperledger goes itself and the blockchain, is there a particular blockchain you're looking at, or a particular technology? Are you looking at Ethereum? What are you building this with?
Well, we looked at Hyperledger and Ethereum, and essentially where we ended up is we just believe that things should be in a public ledger, and so we actually have started rolling out Ethereum, and so for us, we basically want to stay true to distributed ledger and having total transparency on what's going on. And we believe that we have a really pragmatic, easy to understand approach that will work in advertising. And we just want to follow through on that solution. And we believe that that'll work. And, as far as transaction speed, it all depends on how you look at it. If you want to publish every single transaction that's happening, that's going to be a problem. right? But if you want to scale and you want to batch some of these transactions and start to work in batches when you're actually publishing out into the Ethereum network, then all of a sudden that becomes more manageable, right? And as we get better and better and better, those batches will get smaller and smaller and smaller, and we can get better at just the technology and having its role being played out in advertising.
Is there any use cases you guys already have this working on? I know you probably can't name names, but is this already a viable working solution in the market?
It absolutely is. Actually, we're in production right now. We're working with major agencies and major publishers, some of which are public. We actually integrated with Salon Media. We have some others that are in our private beta. I think what's excited about is that I can stand up on any stage and say, hey, you know what? Not only is blockchain an incredible technology, but it's working today, right? And we are well on our way to have this established and having a full solution. So I'm really happy about that.
Awesome, Manny. We have we're basically out of time here, so I want to be respectful of your time as well. I know you're a busy guy. How can people reach you? How can people contact Rebel AI? We're going to also include this information on any of the podcast posts and things like that we put out. But how can people find you?
Well, usually, in the mornings I'm on my bike ride. It's about a 15-mile bike ride, so you can go down Cold Creek Trail back here, and you'll find me somewhere along the ridge. But if you want to contact me via email, just feel free to email me at contact@rebelai.com or email me personally at epuentes@rebelai.com, and I'd be happy to, talk to you about everything we're doing and go as far as putting it on a whiteboard and give you every single detail of how we do it.
Awesome. And you're also speaking at the Global Blockchain Summit next week, so that's actually I'm going to get to see you in person, so I hope to just grab your thoughts around the event while we're there too. Thank you, everyone, for joining us today, and catch us next time. Thanks.